one of the last times I'm here, by the way.
No,
yeah, I
recording,
plan to
yeah.
move back to the Netherlands in like 3-4 months.
That's the thing. Where are you working at right now?
I was working at my own company, Atomics, here, online advertising, but we kind of stopped now. So
All right. So how I implement? I literally do this presentation in 30 minutes. 5:30. So this is a story about how I ends up implementing TOTP. And I have this job interview by HDE. There's actually two parts of the challenge. One part is actually writing some small program without using loop.
Hey, that's the same one I did. No wonder I was actually TOTP. I was wondering, oh, how come? It's the same thing that Sweden implemented.
So
Which one that was do the okay, never mind.
yeah. There's actually a question. So then there's but there's actually a second challenge that they didn't actually say, because what happened is there's two parts. I will only show the second part because the first part is actually the same question and I kind of respect them. So I only show the second implicit part. The second part challenge, they didn't actually tell you to implement a TOTP challenge, but because they actually had a 30-second timestamp. Okay, I'm gonna explain this. The goal of the mission is to submit to a HTTP post or API endpoint. The password is actually a TOTP based on RFC 6238. I will explain what is RFC 6238 later. They give you a key and key step, and this is important. The key step is actually 30 seconds. So you can't brute force it, because by the time you do it by hand, you need to recalculate the time you get. So the easiest part is, the easiest way is to write a code for it. They don't actually tell you to actually implement it in Go. I just do it because it's my own challenge.
Is it the first time you use Go then?
Yeah. No, actually not really. I had this silly API service called Shruti or Not, which I didn't implement.
So you were familiar with Go?
A little, it just had, I didn't have the deep knowledge.
So this is one of your first Go programs?
Yeah, this is the actual probe. And also there's another
Time-based one-time password.
I will explain that later. And here's another part. Most of the library time-based OTP is 6-digit. But
you actually have to submit the program that you wrote?
No. I don't have
to post.
Correct.
Post the URL to the program.
Yeah. So the thing is, most implementation is 6-digit, but the standard, here's the thing. The standard do not actually require only 6 to 8 digit. 10-digit is okay. In fact, they can actually have more. It's just not practical. And also, we use SHA 512.
Oh, 512. Okay.
Yep.
No, it's just because it's not really part of.
No. The standard. In fact, I'm going to open up the RFC.
Yeah, I'm because I told you, right, that I did something as well similar. So I'm actually opening my project, see what I did there. Because at least for me, I wanted an OTP, a TOTP for my own use, so I can log into Google or GitHub or whatever. I needed to.
How do you edit
Ruby?
No. Oh, so here's why the challenge is implicit that you have to implement the code, because most library 6-digit to 8-digit, but not 10.
Yeah, here's one with 6 or 8 digits that you can easily override.
Yeah. But you have to change
right?
You either have to change the code.
It's nice to write yourself.
Yes, it's just fun. So TOTP is essentially a few parts.
I actually made a gem.
Yeah, there's a few of those nowadays.
You know what would be really interesting? Can we go through some, and especially the code? Can we actually compare the differences?
Yeah. I have.
Ruby and
Yeah.
and also maybe the library itself to see how different things.
So this is RFC 6238. 6238 actually two part. One is it's actually an implementation of 4226 HMAC based one-time algorithm, one-time password. And I'm just going to jump straight to the core of the algorithm. I'm so sorry I didn't prepare for this.
Did you bit shift here as well?
Yeah.
Because it's that. I just implemented the.
So there's actually the implementation is HMAC SHA-1, So which is actually which is why the original question is slightly different.
Yeah.
There's a most library allows you to switch to different SHA, I believe, but this one use only SHA-1 and key, and C is actually the counter. So how it actually works is essentially like this. Both have a shared key. Both have shared key. Now when you use the key, you have to add the counter by 1. So 2 have to agree to it. So now you do a third time, now you have counter by 2, counter by 3. And which is why within the standard, the key must be unique between client. That's another reason. So that's how you had a one-time password that is reusable and all that. This is 4226.
So the way HMAC or HOTP is used is like it's never the same
Correct.
count, right? So
It should
you do it
increase.
once, and then the next time you do it again, the counter increases.
Correct.
So it's 2 now, and then you
But can you tell me what's the problem with this algorithm?
it's deterministic.
So it's
Well, it should be deterministic.
yeah.
You have to do it twice.
There is a way for you to actually guess the counter, so you can actually hit the counter and
So
it
it's
can
like,
yeah. But either way, TOTP. I don't believe TOTP is as good, but the idea is that
The key, why is the key there?
it's a private key that's supposed to be shared.
Also,
it's
shared secret.
asymmetric.
Correct.
No, it's just shared
Well,
secret.
in
You have to
theory,
know the.
in this, how would you be able to, you already know the actual seed that's
Yeah.
gone.
Yeah.
But then in this particular case, it's just that even if you can see and actually be able to set the values,
Yeah.
you can't really derive the K.
Correct. So, but what is actually happening is because the key, this algorithm is run on two sides, the server and client side. They're comparing the same value. If the value is same, then you should go ahead. So that's the.
So what's the problem here?
I believe that it's possible to intercept C, the counter.
You are not sending C over, but if you
No,
know
we're
the
not.
results of this one, would you be able to
So ideally, the scenario of using
C in this case is
a counter.
time, isn't it?
It's a counter. No, TOTP will use C as a time. More of that later, but C is a counter now. So use the password type once. So now use one. You will have count 1. I have count 1, 2, 2, 3, 3, 3, 3. So I believe that it's possible to intercept C, but I could be wrong. So go on. No. I'll be spending a lot of time talking principle. I'm sorry.
Which I also did during my talk.
Yes.
So that's why I thought, did you attend it and then you just lifted my talk?
So what happened is TOTP, the TOTP algorithm that replaced the counter with time, and it's actually not time, it's timestamp, and there's a reason for it. The timestamp, the time step. The time step is actually within X. So you see here, T is time step, Unix time minus T0. T0 is the earliest initial Unix time agreed upon. And then X is the how many seconds in between. In this case, 30. Default recommendation is 30, but you can change it by implementation. I do not believe your Google Authenticator based code actually set the T, but I could definitely be wrong.
So it's about 10 seconds.
Yeah.
10 seconds.
Correct.
So the step I think is about 10 seconds.
Yes.
Same with Steam card, same with everyone else.
So I think that's where the standard a little different. This because the recommendation is 30 seconds. So, but it's the same idea actually. So and there's a reason why they had to use 30 seconds. The reason is there is a time drift, so it must be within the range. So which is why they recommend 30 seconds. So also you should do it in 32-bit integer to support 2018.
Oh no! What happens after that day?
No. The number will support.
So you
Went back to 0.
Yeah.
So this is safer than counting because if you do T is just counting, then you can start at 0 and try to.
Yeah. So which is even So the time is guaranteed to be there, but it's not any safer. I do not believe, which is why you don't use it as the primary authentication. You use it as a two-factor. I believe.
That is your, because it's a step counter, right? It needs to be different every time, but because it's blind, the server and the client needs to agree on what the time is.
Correct.
That's why it's time is good because it's supposed at least for non relativistic distances, they're quite the same.
Refuse to implement NTP.
Yeah, correct. But which is why in the standard, they actually assume that the time is relatively, they need NTP, to work, and but the time step allows some drift because the time. So arguably, Golang provide all this, right? They provide HMAC, they provide SHA-32, they can even do base 32. So yeah, it should be easy, right?
How long will it take to do the actual?
1 day.
1 day, okay.
So, a few things they didn't say in the standard, you should pad the key. So because inside, they assume the secret key to be in a certain size format, so you have to pad it if needed to fit the size. You should floor the value of the time step because it's an integer.
It is specified, but you skip through it.
Oh.
They say it was about flooring, so you didn't read the standard yourself?
No, it's not in the standard. It's in the
implementation,
which is in Java.
It's in the implementation.
I had the same issue. I had actually a slide here.
Yeah.
About the same thing.
And also, you should pad the you should actually pad the output because the server expecting the end length of the value. So let's review the ugly code. Jang. Chromecast it. By the way, this code is supposed to be used one time on submit. You want to submit second time, then you.
So one time code to generate, one time password.
Which is right. Yeah. I call this ghetto FTP. I just show the source code first. I show you how to build later.
Go FMT on every save.
Yes.
Yes. I'm not primarily a Go developer. Alright.
Always go FMT.
Okay. So this is the part where we trim the space to pad it, and in this case we pad it with equal. This is the part where it's not clear in the standard, but I find it in implementation.
You know, there's actually a function strings back to pad things.
TIL.
That's a pad.
Yes.
Actually, the story today is assuming it's not a Go programmer, but
Yeah.
for the first Go project, he spent 4 hours.
Yeah, just 4 hours.
Actually, the amazing part is that I'm going to say is that his code, other than the thing, look very similar to some of the code that I write. So.
Yeah. I might have steal your code. So either this is a HMAC with SHA-2. So, and this is the part, and you need to set your number big endian. I don't remember why. I definitely read it from source code implementation. This one I leave directly from the Java implementation.
Same.
Yes, I leave directly. This one is because they need to convert the bytes into 32-bit numbers properly. But I mostly leave this from the implementation. So this is the part where you get 10-digit. This is the actual value where you get your 10-digit OTP, but you get in integer, which is why you pad it with number until 10 character.
I think those 4 lines you can replace by a binary .big endian
Yeah. I'm not a Go developer. I'm a Python guy.
Except the 925 is very awkward.
That's the point. Beginners.
So either way, this is a time step.
Can you share that gist and then we'll do a code review on this?
Yeah. The gist is on the presentation. You want to do that?
No, we'll put it on the show notes.
Okay.
And any other Go developer can do a.
So just remember, in this case, I convert the number to int 64, just so. Then we'll cover that later. But always floor the value so that.
Oh, you're on TOT.
Yeah, floor the value because it expects an integer, not a float. So always floor it, and to use it is essentially that. In fact, the whole TOTP code is 12 minus 49 is 35 line of code just to generate the OTP. I know it works. I have to change the code from the test, but it works. So it's around 35
Did you
lines.
write the tests? They had like some 10. How many tests did they have? Like.
No, I did not follow the test.
9.
I do not implement the
10
unit.
tests.
I did not.
You need to convert to float
He
for
can't
this.
follow the test because he hard-coded the 10 digits.
Yeah.
Those tests are horrible.
Yeah.
It's like this line 48. Could you just divide instead of converting to float and max floor?
I don't know.
Do you need to floor? I mean,
But then it's not gonna.
you don't need floor, right? If you use integer divide, it is naturally floor.
Oh, really? They do?
Around.
They do that?
I think it's floor.
They do that? Huh. See? I'm not a Python guy. I literally implement that.
No, I mean, a lot of the what we actually discuss here is all of low-level stuff. So if you're actually been doing C and all stuff, it's very.
But it depends on your time step because time step could be a non-integer. Well, the way he implemented it is integer. Let me just confirm with the spec.
Yeah.
TOTP time step.
I'm sure I'm doing this because of accuracy or some stupid thing I forget to do.
Or is it the time is actually not in the time is always in seconds.
Yeah.
I forgot, guys. Do you remember time, especially Go? What is
Time is
it?
in seconds.
Seconds. Time now should not be in seconds. Time now is high resolution.
So you have a unit set nano.
Oh, okay, got it.
So either way, it's 35 line that passed the test. By the way, I did not test the full standard. My only test is actually through the API call.
Also, because you passed the API call, then
Yeah.
it's working. Okay.
Yes.
Okay, so out of curiosity, how would Ruby implementation look like?
I can put it there.
Let's
So-
cuss it.
So the time step doesn't say. It just says seconds, but it doesn't actually specify the time.
Yes.
So I don't know. Well, the Java implementation does floor it, although I know that dividing an integer with an integer also automatically floors the thing. But
Yeah.
I guess we just did. So, do you want me to? How do I
Cuss it.
present it? I don't know how to cast stuff here.
You're correct. Yes. Just borrow your.
Yeah.
You're using internet.
Okay. Then yeah. Then I'll just
Just type. Just type.
I don't know what my.
Just type. I show you.
Maybe also spend more time debugging.
A secret key. Lol. Sorry.
So yeah, in that code there, you could just write Unix time divided by time step and it will automatically floor.
Oh, we will find out. Well, yeah. I don't know. We can try it later.
So I mean, I can do it in Python.
Why is your mouse is upside down or something?
It makes sense for me. It makes sense for me.
Curious.
So old school.
Did you actually adapt a lot of this from the Java program?
There's 3 source. No, there's 2 source actually.
Why
reference
you even
implementation
have
feature.
tap to click?
Okay, perhaps it's not such a good idea.
So one is of course the Java one, because I don't get too much value that do it in Java this way, so I try to convert that. Then the other one is actually the libraries.
How do I cast this particular page there?
Okay, I'm doing it right now. Chrome.
It always fix on the UI for.
Let me. Yeah, I'll quickly do a.
So we're pouring some code today.
Now we're just comparing some of the
Yeah.
same implementation.
All right. So here it's the same thing, secret and the digest factory, I did it as a presentation, so I had to do best practices there. So you of course create like all of these things, right? Like assuming that you want a different digest factory, for example, you can pass in whatever digest factory you want. So in Swimming's case, it's 512. The spec says it's SHA-1.
Yeah.
So that's also what Google Authenticator uses. Most of the other stuff use. So it's by default like that. And then of course you create the HMAC. It's the same thing. The spec did not say about the padding, but the Java implementation, reference implementation did. So that's what I did as well. And that's what you pass into the hex digest. I think I spent like a good number of hours figuring out why it wasn't. Sorry, can you go back to a bit later? Why it wasn't accepting the thing? Like the tests are failing because I realized, oh yeah, I had to pad it with zeros, or like to the left, to the right.
Yeah.
Oh wait, sorry, to the left. I right adjust it with zeros.
Yep.
Basically, you were saying swimming?
No.
Yeah. Okay. Yeah. So this is HMAC. So it's a convenience function. This is the actual generation of the OTP. You'll probably remember swimming saying about this, the key and the step and the moving factor. So this is the moving factor that increases or is expected to increase. Those are annotations because Java has the bytes, and I had to remember what their types are, because in Ruby you don't have types, so I don't actually know what the type of a variable is during runtime because it can change.
Want me to go down further?
Yeah, sure. This is the same thing this is mostly like swimming lifted from the Java implementation because I have no idea what's happening here except for the bit shift. I understand the bit shift. I didn't know I had to end it with 215. I had to all of these things. It's part of the specification.
Yeah, within the spec, they actually describe that it's fit the 32-bit integer. You're converting the bytes to 32-bit integer so that it can actually fit correctly. Yeah.
Oh well, that's the bit shift. Yeah. The truncation offset stuff is the one that I don't understand. Yeah. Like this, the bit shift is the one that jams all of the results into a single 32 int. Yeah. And then OTP, that's where you convert that int into digits, basically. Yeah. And again, the padding of the digits with zeros, so that it starts with 00 basically. If you don't have anything on that value, because it's a number, right?
Then you just do all these things with just one printf. Is there printf in Ruby?
There is, yeah, but it's it's a presentation, so I want to be clear what exactly is happening. If you do a printf, it's like, oh, magic, yeah.
Printf is slower.
Oh yeah, so as part of the presentation, that's actually a good thing. One of the specifications, it's I think, let me just quickly get that because it's
47 lines of code.
Yeah.
Okay.
No, it's not about that.
You lose.
Yeah.
It's no. This is just no. This is just HMAC based. Because time based builds on top of HMAC.
So
go to the next
file. In this case, that if you initialize, you just pass the time to.
Yeah, but it's different. So you because the specification. So there's a smudge factor of like the recommendation is 30 seconds. So you have to
truncate the.
No. So can you open a TOTP, the next file?
Okay. If you ask for a shortcode in Ruby, it's like asking for shortcode in code. It can be really short and not beautiful.
Yeah.
Isn't that a good thing?
Yeah. So one of the things on
assembly programmer. So
yeah. So one of the things. So that's why the printf thing is not usually used, because one of the requirements is that the algorithm is a should clause. Should be economical to implement in hardware, because you'll have hardware based HOTP generation. So you can't really expect them to do printf. You probably do have like a small chip, but no, all it knows is to do bit shift. So that's why it's done bit shift in the reference implementation. So this is the time-based one-time password. So basically, it builds on top of HOTP. So again, the time is an integer. Here, the moving factor is whenever you basically divide the time with the time step, which is 30 seconds in this case, and you actually have 3 because of the smudge factor. So the spec says you have to allow like 30 seconds in the future and 30 seconds in the past, and accept that.
Can I ask a related
relevant questions from different approaches from different languages, including Python. How would you guys test this?
There is a test actually in the reference. If you can I didn't open it, but you can open the spec.
As in
the
those,
6.2, the time-based one, or
I'll just go to my
HOTP?
GitHub.
Okay.
Yeah.
especially if the OTP is actually time-based, how would you be able to?
So the reason why I separated the HOTP with OTP is because if HOTP works, then you just like if you've tested it working, and this is the great thing about unit tests, right? If you know that this particular section is working, you isolate whatever is working and is already tested from the untested code, which is the only thing that's different from TOTP with HOTP is that you have a time component there. Yeah,
So,
can you go to the spec? Yeah, feature spec. So this is also from the reference implementation.
So there's a reference
It actually has a secret key that they say should result into these. And so if you run this, then and all passes, then you know you have implemented it correctly.
Yeah, I didn't do that because I kind of want to submit the test.
So that means is that rather than just doing the time-based OTP, is that at least the
You
time
start
is
off,
actually
yeah. You
quite
start off with the foundation, which is HOTP.
Yeah.
Make sure that works because the only difference is that now you have a time, and you divide it by the time step, which is 30, and then you have the integer.
Yeah.
If it works from 0 to 9, then most likely it will work for whatever other integer works.
Yeah, because most of the work is actually on the HOTP actually. Time is just a calculation again, so.
okay.
And if you want to test something with time, you always add the function to get the current time as an argument.
Then,
Yeah,
yeah,
right.
exactly.
Yep.
Then that makes your tests not so fragile.
Yeah.
What's the word for that? Stable, consistent.
Yes. Well, yeah, not fragile. Basically, we talk about the negative ones. The fragile tests, you don't want fragile tests.
So
The other ones are like given, like those are normal test and a fragile test.
So and I managed to do it in a day.
Yay!
Actually, it's more like 5 hours or so. So
Uh,
that.
So technically, that you consider yourself in this case is like very into any comments in terms of Go and any biggest gotchas.
Surprisingly, if I were to do it in Python, the code would most probably look similar step and all that because type conversion, mostly because of the type conversion actually. Because we have to shift the bits, those you cannot avoid. Maybe you have some floor function, but that is standard stuff. So the step will be the same mostly, but so I don't see. Maybe the library is slightly different, but not by much. I suspect not by much. So ta-da!
Yay, thanks.
Yep.
Do you have any reference of how the Go people are supposed to be doing this? The standard library.
Some of the code different.
I set it up to be on Taxuri guest, so everybody that on
Yeah.
guest can
Connected to the Wi-Fi home. Anyone?
Can cast there?
Yeah.
Do you want to learn more about OTP?
Actually, it's more like a
Can we have
experience and
Yeah.
about.
Also, I tried. I've been trying a bit of Go. Like one of my like observations there is that it's quite straightforward, and it's very like you basically say what you want to say without any. Because we're used to Ruby Magic, for example, right? Okay, it's very different in Go. And what would you recommend, like someone learning Go to start doing? Like for example, in Ruby, or in Python or whatever, I would usually, or at least learning new languages, I would usually write a calculator where you actually do 2 plus 3 times 4 plus 7, and it calculates the whole thing.
Definitely, it's just that anything that you can actually fit into a single file at the beginning. So at least you get used to
Do you
some
have
of the
suggestions, for example?
I don't know. For me, is that a lot of it I get started and got a hang of it by running through those programming contests, programming puzzles,
Programming like Project Euler or
those kind of things. Yeah. So it quickly get you to different things such as opening different files for different outputs, how to handle those inputs, how to process them. You quickly get used to some of the string processing. Then after that would be writing a very simple back-end web server that does minor calculations and stuff. So those kind of things, at least it's such for me. But one thing I recognize is that different people, they have different preferences. So certain things works better for different people than for whoever. So I think I'm coming from a more low-level background. So I'm pretty okay with some of the lower level stuff, bit shifting and the green wrangling and the bytes handling of code. So having access to those low level stuff actually helps a lot of those fun little optimizations that I can actually do without actually going through, oh okay, I'm gonna run it in C again and having to handle the biggest problem for C last time for me was that the memory management and handling of strings and the zero terminated strings are very much of annoyance.
But it's a good introduction for I can give a small presentation.
No, but you mentioned about those optimizations through bit shifting, but are the gains and optimizations on there like overcome the garbage
you don't
collection
garbage collections
cost?
are when you actually get back the memory that you allocated. So
but
if you're actually doing some of the low level stuff, you will realize is that we don't really do that much allocations anyway. So most of the times that you allocate enough memory you want to work with and you just work with them.
Yeah, but I'm saying that because you have to set the time, like is it still the world stops and then the garbage gets collected, or is it
No,
Yeah, but the world stop is only like nanoseconds almost.
yeah, but
it's
the gains on bit shifting something.
It's not just the bit shifting.
No.
It's just two different topics.
More gain to I will do some stuff. Now there's more gain to making sure you don't allocate anything. So let's talk some low-level Go stuff.
Okay.
So not everyone you're not super familiar with Go. So I'll explain quickly what this is. This is a small program. We have a string, foobar. I will show you that in Go, strings are actually immutable, which means that you can't change them. And once you have a string, it's always fixed. Don't pay attention to this first line. It just makes sure I can have multiple main files in one directory. So I'm trying to...
I did know that. Okay, now I'm learning you.
Yeah, I have like 1, 2, 3, 4, 5.go, and they all have a main function, but if I compile, I don't want them to complain that I have multiple main functions. Okay. So I try to set the character number 4 to a B, so it would be, I want to set it to a O actually, sorry. So it would be foobar instead of foobar. So if I run this, go run on, it's gonna complain like cannot assign to because a string is mutable. So in Go, what do? If you have a string and you want to change something, you change it to a slice of bytes or an array of bytes. So here I change S to a slice of bytes, and in those bytes I can change character number 4 to an O. I print both of them, first the byte slice, then the string. And you will see first the byte slice, there it was actually changed, so it's foobar, but the string, because it was immutable, it didn't change. So what actually happened here is, on this line, it made a copy of the string in memory. And that's heap allocated. That's something you don't want, usually. Do I have this? So what you can do, and this is super ugly, but sometimes you want the performance optimization. Yeah,
I understood the others now.
So don't look at that function yet. So we have here our string S. Now instead of casting it to a slice of bytes, we call this magic slice to bytes function. Set byte number 4 to an O, print both of them, go run 3.go, and you'll see, error. I'll get to that later. First, I'll explain, maybe I should show number 4 first. Because, okay, the issue was this function, and I'll explain the function later. This function, it makes sure that the byte array points to the same memory as the string. But I'm trying to change byte number 4, and this string, because it's already fixed here, it's put into the read-only section of my program. So I'm actually trying to change a byte in the read-only section, and that's exactly why it says, I do it like this, it says unexpected whatever address, it can't write there. So we need to write into a string that's actually not in the read-only section of my program.
Wait, that was a runtime error, right?
Yeah, it was a runtime error, yeah.
Interesting.
So I tried concatenating two strings together, so I would think like foo, the string bar would both be in like the read section of my binary, and then the concatenation would be in normal memory, but no, Go is smart enough to at compile time already combine them. So I have to do it with this, for example. I just concatenate the two strings using printf. Now the compiler is not smart enough, so S will actually be on the heap in writable memory. Then I convert it to a byte slice and change number 4. Go run O. And it actually works. The byte array changed and the string, which in Go is immutable, actually changed. So let's see at what that function actually does. And then we start by looking at this. So in Go, strings are actually what is it? Pascal strings. So strings don't have a null terminator, no, they have data and a length. Oh, sorry, this is the string header, data and a length. We can see that if, for example, here we have a string with a null inside of it. If I print that, it will actually, well, it can't print anything, but it will print the rest, so it will print playground. If I have that in C, is that readable? Plus, 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 plus. So in C, strings are actually null terminated. So in C, if I put a 0 inside my string and I run that, well, you can already see the result. It's going to stop printing there because it sees that at the end of the string. So we know in Go, strings actually are represented with a string header, which is an internal structure. It is exposed in the reflect package, but there's a warning here that says that it might change in the future. And we can see the string header actually has the data, which is a pointer, and the length. But if you have a byte slice, it's actually quite comparable. A byte slice also has a data pointer, a length, and it has a capacity as well, because it might be longer than the current usage might be longer than length. So what this simple function actually does is it casts our string to a pointer to a string header. So we actually have a pointer to a string header now. And then we build a slice header with exactly the same data pointer, with the length same, and we set the capacity to the length as well, and we return that as a byte slice. So what this does is convert internally the string header to a slice header.
Is this how you implement unions?
Unions? No. I don't know, how would you?
Unions when you know, the same memory address can be two different types. You can actually do that.
This is what you do if you have, I don't know, a lot of stuff where Go, for example, you have the strcomp package.
That explains so much.
So I have the package to convert strings to stuff in Go. All those functions always take strings. Like if I want to parse an integer, it takes a string. I want to, I don't know, parse, I want to string to an integer. It's all with strings usually. So if you have a string and you want to quickly get an integer out, parse it to an integer, normally you would have to allocate on the heap because you need to cast it to a string. So with this function, you just pass it the original bytes, or oh, that's the other way around. Sorry. If you want bytes, yeah, there's definitely some speed and performance to get. So let's see. I actually wrote a. What do I have? Here is a small benchmark. So. Here we're going to benchmark if we cast a string to a byte slice and then change one. But I called that benchmark wrong because Go is a bit smart. So this string is only 6 characters long. If I change it to a byte array, it's gonna make a copy, but it's so small that it's just gonna put the copy on the stack. So it's not going to cause any heap allocation, so that's still fast.
Well, but you're not, if it's on the stack, are you, because it's
and
a
I can
byte
still
slice,
change
yeah.
it, but it's inside there.
Yeah.
So I actually tried it, and if I repeat that string 5 times, it still allocates the copy on the stack. So it still says like, oh, that's small enough, let's reserve space for it on the stack. Sorry?
How do you know it's allocated on the stack?
We'll see that soon. So here, this benchmark, I copy it, I repeat it 6 times, and I do this, and now you'll see if I run this.
Before we continue, since I do know C and I know the difference between heap and stack, anyone else from not doing C understood what's the difference between
Oh yeah,
stack
does
and
everyone
heap?
know what's the difference between heap and stack? Yeah. So the stack, every time you call a function, your program will allocate some memory on the stack, and arguments and stuff will be allocated on the stack. When your function returns, all that memory is gone again. So the stack is something that just grows, you put stuff on it, it automatically gets less again. The heap is, it just stacked memory on the stack gets automatically deallocated when your function returns. Stuff on the heap is stuff you allocate usually with malloc in C or whatever. Stuff on the heap needs to be freed manually. So Go, if you have stuff on the stack, if a function returns, it's gone. But memory on the heap needs to be garbage collected. So if you want really fast Go programs, you don't want stuff on the heap, or at least as little possible on the heap, so the garbage collection is as fast as possible. So
Or there's no garbage collection at all with the stack. It's
no,
purely
stack doesn't have to be garbage collected. No,
So
the stack just, the memory is freed as soon as your function returns. But there, so if you have stuff that lives longer, stuff that lives in your global scope, for example, or stuff that lives between functions, then it needs to be allocated on the heap, because you can't keep it on the stack. So here I run the benchmark. Go, for the people who don't know Go yet, Go has this easy bench tool, where I just say run all the benchmarks which match the regular expression *3*, and bench the memory allocations. Here you see that first run where I said it would place it on the stack. Okay, it's wrapped a bit, but you see it took like one iteration of that loop, took like 7 nanoseconds, 0 allocations for operation. So it didn't allocate anything on the heap. Everything was on the stack. Then that one where I replaced it, repeated it 5 times, still 0 allocations on the heap. Then when I repeated it 6 times, it says 1 allocation per operation on the heap. So this one, here it actually made an allocation on the heap, because it said, oh, you want a copy or a writable copy of that string as a byte array, then I have to make a copy on the heap, because it's too big to put on my stack, because only a certain amount of space is on a stack.
Does Go have a way to force it to go to the stack?
No. So that's why if you
don't
run
want
really
it to be too
performance
much of a stack,
programs, you always
in case
have to,
you have stack overflow.
you have to play around with this.
No, well,
and
you know how many times it will run, right? But I guess Go just wants to.
Go at compile time, it does some analyzing and says, it sees like, oh, this can be on the stack, this can be on the heap.
You can't
whatever.
have like annotations, please,
No.
or hints, for example,
No.
hints.
No.
Okay.
But it's already better than, for example, Java. Java is just everything on the heap. Like it doesn't even use the stack, or barely uses the stack. It just, every object you allocate, or put it on the heap. So that is a lot heavier for garbage collection. Go, a lot of the stuff can be on the stack. So, oh wait, no. So now we have the same benchmark again, only now we use our function. And then you can see here, I'm just gonna, well, I repeated it a lot of times for this one. So it's definitely we'll want to put it on the heap if it can. But you'll see, I use my function, so go, whatever, test. If I run that one, you see 0 allocations. So that one, because it uses that internal function thingy, or that nasty function, it doesn't allocate anything. Here you can also see, by the way, if it can place the string on the stack, it's like 8 nanoseconds per loop iteration. But if it needs to make a copy on the heap, it's 42 nanoseconds. So it's a lot slower also, because it needs to allocate memory on the heap, copy it to it, which is a lot slower than if it already at compile time reserved memory on the stack. We also have the other way around, and this one is more interesting, because the function to get a string out of a byte slice is a lot shorter. Why is this so much shorter? That's because, if we go back to our internal memory stuff, so here we have a byte slice, and a byte slice header starts with a data pointer and a length. And we want to make a string header, but string header also has data and length. So in this case, we can just cast the same memory to a string header, and that's it. We don't have to do anything. With this function, we actually have to build the whole slice header manually, because we have that extra capacity. So we can't just cast this one into this one, because then this field is some memory address, some memory location that we have no idea. We don't know what's behind this string header. So that's why this function is a lot shorter. Here we have the same foobar written in bytes. We build a string out of it, and we print both of them. Then I change the byte array, but of course this byte array is just points to the same string. So if I change that and I print the string here, I don't print the byte array, I print the string is also changed. So yeah, the string was also changed. If I do here, instead of this function, I do string b, then of course changing this byte array is not going to change this string, so this string should still print foobar. And it still prints foobar. Did I also have a test for this? Yeah. So here I also have a test. So here I have I repeat it 6 times again, so it's allocated on the heap if I do this. So here I make a copy just by casting it to a string, and let Go do the conversion. Of course, Go is going to make a copy on the heap because strings are immutable, so changes to our byte array shouldn't be in our string as well. And here we do it with our own function, and then you can see Go. And then you see that first one, yeah, if you cast it to a string, a byte array, then it allocates one, and if you use that function, then it's 0 allocations, and a lot faster because, well, basically you only change the header, you only change one pointer actually. And that's my lesson about strings and in Go and immutable strings and performance optimization. And I'm adding a big warning to it that you only need this if you need really, really high performance. Normally you never use this in Go. This is like really nasty. That's why it also says here, it cannot be used safely or portably as in % may change in the later release. So this is really internal data structures for Go that can be changed whenever they want.
And that looks really dangerous.
Yeah, that's definitely dangerous.
But it's about 10 times faster.
But usually pointer operations are dangerous.
It's like driving a fast car.
No, Go is full of pointer stuff. You use pointers in Go all the time.
Yeah, but I mean,
But
pointing
normally,
it somewhere else. With
you
type
something
change.
like this. Yeah.
You still can
Changing
do a lot
the
of
type.
evil stuff if you
So while Go it's like a high-level language with garbage collection and makes stuff easy, you can still do low-level stuff if you really want to.
It's particularly of interest for those used to the really low level.
Go had method to not use the garbage collector.
No, you can't turn a garbage collector on. It's really needed.
It's very dangerous.
Yeah.
Don't trust you jokers for you.
But did you see how fast it was? It's worth it, man. That's how you get up the leader.
Sometimes it's definitely worth it. For us, it's worth it.
If you have very tight loops for certain things, it's actually a few custom things is actually much faster than your general solutions. Like one of the things I'm actually screwing around now is that sometimes I just gave up on classic search or even Postgres, not everything manually. The thing about Go is just that even though it's actually compiled at some high level, it's just that if you know the structures enough, if you dare enough, you can load a lot of things straight into memory and things will be much faster in memory, and just forego the fancy stuff like in other languages. If you need certain things, you still have to rely on SQLite or Postgres or Redis or whatever for performance for your data. So,
like for example, in the old times, games save files are actually memory maps. So it's like you can know how the C structure was on the save file because they just basically malloc the whole thing, point the pointer to the file, and then it's already there. Your structure is filled in, and so that's very fast. You don't have to actually read it and then instantiate an object and then assign.
But these days you can't do that because these days you don't know what memory address you get because most operating systems have memory address randomization to fight viruses.
And old days of DOS, yay!
I want to say one more thing. I don't have a job at the moment. I'm still in KL for like a couple of months, 3-4 months. So if anyone has anything for a couple of months, my resume is on GitHub.
One thing I want to point out is
for good.
Actually, this is my resume. You can find it here in here somewhere.
It's actually good. This is like a self-filtering thing. Technical recruiters who have no idea how to recruit technical people will probably not know how to access GitHub, right?
I have one. I'm looking for a job in the Netherlands now because I moved back to the Netherlands, and I had one company already contact me, and that was very interesting.
One thing I really need to point out, if you guys haven't realized, is that Eric is really good at making things run very ridiculously fast.
Yeah. So my company that I worked for was atomix.com. It's loading. We were an online advertising exchange, and we were doing we had Go programs that were handling thousands and thousands of requests per second. So that's why we needed online advertising. So for each HTTP request, you have like 100 milliseconds to respond. So that's why I do that Go level, low level optimization stuff because we really need that. But I've done other stuff as well. I have lots of experience. I can do C, C++ as well, Python, Node, Java, whatever.
Were you at Mininova?
Huh?
You what? You founded Mininova?
Yeah. Mininova was my...
I didn't know that. No!
What? He mentioned that in the early days.
Okay,
that was my company, Mininova.
Oh man!
That's how...
The amount of...
stuff you downloaded there. Yeah,
yes.
That's a lot. It's a clone of Supernova. First Supernova.
Yeah, Supernova stopped at some point. Those were the fun days.
What do you mean?
Damn kid.
There's a lot of... There must be a
Damn kid.
Many years ago. When you're still furry.
I think I still have my username, account, password stored somewhere for my Mininova site.
Well, the site is online, but I still have the database.
No, I didn't reuse my password. So.
Depends on what time you set your password, because at some point we were only using MD5 for passwords.
That was common.
No, but because we didn't know about the rainbow table before.
That was even before. I was like the first year was in university, so I didn't know that much yet about stuff like that.
And then people will laugh at us for using SHA-256 when the rainbow table appears for SHA-256.
Yeah. SHA-256 is still breakable. I mean, just the key is you need to sort the thing.
Yeah.
If you sort it, you're fine.
Where they use now passwords?
No, TOTP. Did you listen to something?
Use printf to format your query and tell me your website.
That is so evil. I like it.
I have to say with Mininova, we never got hacked or anything, so
Yeah, I didn't
something
have
right.
thing, so yeah.
What happened after that? Was the government or someone actually?
Yeah, this not the government, but the organization, Brein, it's called, was an organization.